Good morning everyone. Myself V. Surya Pavan Kumar, working as an assistant professor in CSE AIML department in MLR Institute of Technology. So in this class, I am going to discuss about data link layer. So in the last sessions, we had a clear discussion about OSI model. In that particular OSI model, we have different layers like physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. And we had a clear functionalities of each and every layer. So in that, we will clearly discuss about the data link layer, what is happening in the data link layer and how the data will be transmitted in the data link layer. Each and everything will be discussed in this particular topic. So first topic in this particular data link layer is design issues of data link layer. So before going to discuss about this particular design issues of data link layer, so how the data will be transmitted in the data link layer and from where the data will be coming to the data link layer. So for example, if you go through the previous one, the data will be coming from, so for example, this is a sender side and this is a receiver side. The data will be coming from, say for example, these are how the data will be transmitted: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. In the same way, we will be having at the receiver side also. So in this particular data link layer, the data will be transmitted in the form of frames usually. As we are discussing about the data link layer now, so we will clearly discuss about each and everything with respect to the data link layer. Actually, for this particular data link layer, the data will be coming from its higher layer, that is network layer. So how the data will be transmitted in the network layer? The data will be transmitted in the form of packets. The data which is coming from the network layer in the form of packets will be converted into frames in this particular data link layer. And these frames will be converted into bits in this particular physical layer. Right? So now we are going to discuss about clearly about the data link layer. What is the use of this particular data link layer? Each and everything we are going to discuss. Now, so first the topic which we are going to discuss in this particular data link layer is design issues of data link layer. So what are these particular design issues? So why we need to address this particular design issues? Whenever the data that is coming from the higher layer, that is network layer, which is in the form of packets, they must be converted into the frames in the data link layer. So whenever it is being happening, whenever the data in the form of packets is going to convert in the frames in the network data link layer, there will be some design issues. Until that, the first design issue is services provided to the network layer. What is this particular services provided to the network layer? So what kind of services it is going to provide to the network layer? So already we have a discussion regarding how the data will be transmitted from one layer to another layer. So how it is going to serve the network layer and what are the different kinds of services that it is been offering to the network layer. Under it, the first one is unacknowledged connectionless service. So if you just justify this particular service like unacknowledged in the sense there is no acknowledgement from the receiver. For example, here is a sender and here is a receiver. So whatever the data that is being transmitting by the sender in the form of frames, say for example, this is a frame. So for this particular frame, the receiver will not send any kind of acknowledgement to the sender. So there is no guarantee that whether the data transmitted by the sender is going to reach to the receiver or not. So that is unacknowledged. The name itself indicates that is unacknowledged. Connectionless service. So in the previous videos, I had a clear description, I had clearly discussed about the differences between connection oriented and as well as connectionless service. Usually in connectionless service, the data will be transmitted in the form of datagrams. It will be transmitted in the form of datagrams. So what is the main issue in this particular connectionless service is that, say for example, if the data is being following one particular path to reach to the receiver, it is not sure or it is not required that rest of all the data must follow the same path to reach to the destination. That means different datagrams will travel in different directions and they will be using different kinds of paths to reach to the destination. So that is connectionless service. So there is no requirement of connection establishment here, and there is no requirement of connection termination. Nothing is being required with respect to this particular connectionless service. So the protocol which is the best example for the connectionless service is UDP. What does UDP stands for? User Datagram Protocol. So whenever the data is being transmitting in the form of frames from sender to receiver, there is no acknowledgement from the receiver to the sender. So there is no guarantee that the data which is being transmitted to the receiver is reaching to the receiver or not. And that is one of the services which is being provided by the network layer, by the data link layer to the network layer. And the second one is acknowledged connectionless service. So acknowledged connectionless. So see here, acknowledged connectionless service in the sense, for example, here we have a sender and we have a receiver here. So say for example, the data is being transmitted by the sender to the receiver in the form of frames. And whatever the data that is being transmitted by the sender to the receiver, for that particular received frame, receiver is going to transmit the acknowledgement. Acknowledgement in the sense, the acknowledgement might be in the form of positive acknowledgement, it might be positive or it might be negative. So positive acknowledgement in the sense, the data which is being reached to the receiver is perfect and there is no errors in that particular received frame. So that indicates the positive acknowledgement. Negative acknowledgement in the sense, whatever the data that is being reached by the receiver, it is corrupted frame. So whenever the receiver receives the corrupted frame, simply the receiver will send a negative acknowledgement indicating that retransmission of the frame. So negative acknowledgement clearly indicates the retransmission of the frame. Positive acknowledgement indicates the transmission of the next frame which is being having with the sender side. That is acknowledged connectionless service. And the third one is acknowledged connection oriented service. So whereas in this particular connection oriented service, so there are three steps that is being happening with respect to connection oriented. First, connection must be established. Connection establishment. So what are the steps that is going to be happening in the connection oriented? Connection establishment. Second one, data transfer. And the third step is connection termination. So these are the three steps that is happening in the connection oriented service, which is not required in the connectionless service. So connection oriented in the sense, so that is acknowledged connection oriented. So here we are also having the acknowledgement. For example, if we consider the same diagram, sender, receiver, right? So before transmitting the data, connection must be established. Both the sender and receiver must come to an agreement that I am ready to send the data and the receiver must be in a position to receive the data. So once the connection has been established, so the data transfer will be taking place in the form of frames. And for this particular transmitted frame, acknowledgement will be transmitted by the receiver. Once the transmission of the frames is being done, whatever the frames that is being happening or having at the sender side, if all the frames have been transmitted and if all the acknowledgement have been received by the sender, then connection termination will be happen. What is the reason for the connection termination? The main reason is that whatever the bandwidth that is being utilizing by the sender and receiver, for that is the communication channel bandwidth which is being utilizing by the sender and receiver for transmission of the data, if we release that particular bandwidth, the other sender and receiver can make use of that particular channel's bandwidth for the transmission of their own data. So that is acknowledged connection oriented service. So this is the first service that is being offering by the data link layer to the network layer. And the second one is flow control mechanism. So what is the concept? One of the design issues of this particular data link layer is flow control mechanism. So what is the main concept of this particular flow control mechanism? See here. So what is this particular flow control mechanism? So for example, why do we require a flow control mechanism? If we are having the fast sender and a slow receiver, then what happens if you are having the fast sender and slow receiver? It ultimately leads to a problem called flooding. It ultimately leads to a problem called flooding. What is the concept of this particular flooding? Flooding ultimately results you overloading of data, whenever, or we can also call it as overflow of data, which ultimately leads to loss of data. So these are the problems with the, if we don't impose a mechanism called flow control mechanism. Simple example. For example, here we are having a sender and we are having the receiver. If the sender, for example, per unit interval of time, if the sender is sending 100 frames of data at a time, sender is sending 100 frames of data at a time to the receiver, but the receiver is having the finite buffer space and the receiver can accommodate only 50 frames of the data. What happens? Rest of the 50 frames of the data will be lost. So what happens? To overcome this particular loss, we use this particular flow control mechanism. Flow control mechanism in the sense, just the sender and receiver must come to an agreement that I am in a position to receive only at this particular speed of the data. You just slow down the process of sending the data in the form of frame such that no loss of data will take place. That will be happen with the help of a protocol called stop and wait protocol and sliding window protocol. So what is this particular stop and wait and sliding window? Will be coming, we'll be discussing it in the coming session. So stop and wait, simply just to giving the overview of the stop and wait. Just so for example, if you take the same, so first the frame will be transmitted by the sender. So this is the frame which is being transmitted by the sender to the receiver. A receiver, after receiving this particular frame, he will send an acknowledgement. Stop. He will be, once the frame is being transmitted by the sender, he will stop and wait for acknowledgement from the receiver. Once the acknowledgement is being received by the sender from the receiver, he is going to transmit the next frame. So here we can overcome the problem of flooding. So flow control, if you don't impose a mechanism called flow control, the problem arises. Such problem is called as flooding problem, which can be avoided using the stop and wait protocol and the sliding window protocol. So this is about, and in the coming sessions we'll be discussing about clear description about the stop and wait protocol and sliding window protocol. And next design issue is framing. So framing, so here actually we have a framing concept. See here, in the framing we have three types. One is character count, another one is byte stuffing. This is a character count. Another one is byte stuffing or character stuffing, and the third one is bit stuffing. So what is this particular frame? See, what is a frame exactly? Frame in the sense, frame is nothing but group of bits. Frame is nothing but group of bits. So how the frame format will be? So this is the frame format. Actually what it includes, frame includes the header part, a payload part, and the third one is trailer part. What this particular header part includes? Header part includes the addresses. That is source address, destination address. What is this particular payload part? Payload part is nothing but an actual data. And the trailer part, what this particular trailer part contains? The trailer part contains error correction and error detection mechanisms. Error detection and error correction techniques. So this is a frame. Sending a frame from sender to receiver is nothing but a framing. So what is this particular, how you are going to do this character counts? In olden days we use this particular approach called as character count. What is this particular character count in the sense, say for example, sender has to transmit the data, just a minute. So what is this particular character count? So why do we use this particular character count? In olden days we use this particular character count. For example, sender is having, this is the frame that is to be transmitted. For example, so we have in a single frame we have 3 frames. So how we are going to identify that it is a start of the frame and end of the frame is that the first part or the first field in the frame indicates the number of characters in that particular frame or number of characters included in that particular or count of that particular frame. For example, this is the header part to including that particular frame. So see, for example, this is one frame. So the start field of the frame is 3. It includes, so this is one frame. So why I am identifying it as a one frame? What is the starting field in the frame 3? Including that frame, it includes the number of characters in that particular frame. That means this particular frame should contain 3 characters. 1, 2, 3. For example, if you go for fourth one, for example, if the second frame is 4, including that frame, the number of characters in that particular frame must be 4. Like 7, any number you can take, 8, 2. And this is a second frame, frame 2. This is frame 1. And for example, if you have one more frame, for example, you have frame like 5, 9, 11, anything you can take, 12 and 7. So that means here you are having 5 characters in this particular frame 3. This is the frame that is you are having at the sender side. Whenever you are transmitting this particular frame to the receiver, what happens? For example, see here, the first frame have been reached to the receiver perfectly. 1 minute. The first frame have been reached to the receiver perfectly. So that is, it receives the frame. So here it receives the frame as it is. During the transmission, the data have been corrupted. So rather than transmitting the fourth frame, that is the second frame contains the first bit as 4, but it receives as only 2. So that means it includes only these 2. This is one frame. And again the rest of all the bits will be changed. And what is the third frame? For example, if it is 5, rather than 5, now you will include 5, 7, 8. All these things will be included. That means if there is a change in a single bit of the data, you are going to change the entire frame. So retransmission, which is not possible, that we call it as a character count. And the next one is byte stuffing or character stuffing. So what is this particular byte stuffing or character stuffing? Stuffing in the sense adding extra bit. Stuffing means adding extra bit. So how the frame will be? So here we have a frame like flag which contains some special characters. Next, header part, data part, that is the data coming from the higher layers, and flag. So flag contains some special characters, and this is the data coming from the data will be coming from the higher layers. Header part will include the addresses, source address and destination address. So this is a flag, right? So for example, if the sender wants to transmit like this, the data which is being transmitting by the sender is A, some flag and B. Whenever a special character is being identified by the sender, what he will do is that he will stop with one more extra character called as escape character. So this is before stopping. This is before stopping. And after stopping, the data A, as this is a special character, it will be stopped with one more special character called as escape character, and the data as it is, and B. This data will be transmitted to the receiver. Whenever the receiver receives that, simply will discard this particular escape character and consider the remaining data as the original data. That is what the byte stopping or character stopping is. And what is this particular bit stopping? So bit stopping is nothing but stopping the extra bits. So bit stopping in the sense, so adding one more bit. For example, after 5 consecutive ones, he will be stopped with one more 0 character. For example, the data which is been transmitting by the sender is 1 1 1 1 1 0 1 1 0 1 1. So after 5 consecutive ones, actually this is this particular format will be at the flag. It indicates the flag. Flag indicates that it is the start of the frame, and another flag indicates that it is end of the frame. So in order to overcome or differentiate between the flag and the data, whenever the 5 consecutive ones appears in the data, it will be stopped with one more extra 0. That we call it as a bit stopping. So here 3 5 total 5 ones, 1 2 3 4 5. After that he will be stopping with one more 0, and the remaining data 0 1 1 0 1 1. So this is a stopped data. This will be transmitted to the receiver. Whenever the receiver receives this particular data, he will simply de-stop this particular 0 and we will be considering the rest of the data as the rest of the bits as the data. That we call it as a bit stopping concept, right? And now is error control mechanism. Why do we require error control? We have some phases with respect to error control mechanism. So whenever the data is being transmitting from sender to receiver, it is not 100% sure that the data is going to reach to the receiver. So the data might get damaged, data might be lost, or data might get corrupted. So what is an ultimate goal of this particular error control? Retransmission. So what we need to do in the error control? Retransmission must be done. Retransmission of data must be done. So how the retransmission will be done? Either it depends upon the acknowledgement. Acknowledgement will be of two types. One is positive acknowledgement and the second one is negative acknowledgement. If it is a positive acknowledgement, no need of retransmitting the data. It indicates that the data which is being transmitted by the sender is error free. If it is a negative acknowledgement, simply it indicates that sender has to retransmit the data once again. That is about error control. We have different error control mechanisms like checksum, next Hamming code, and the parity check, and we have CRC, cyclic redundancy check. So these are all the different error correction and error detection mechanisms. So once if we are not having any error control mechanism, what will happen? The data which is being transmitted by the sender might not be reached to the receiver. The data might get corrupted, the data might get lost, anything might be happen. So this is error control, which is being offering by the data link layer to the network layer. And the other one is medium access control. So medium in the sense, here we are calling it as a shared medium or communication channel medium. So for example, what is this particular medium access control in the sense? If two or more systems or stations are competing each other to access this particular communication channel. So for example, this is a communication channel. If two or more systems are competing to access this particular shared medium, which station must be given the highest priority, either the station 1 or station 2. So based on some parameters, the data link layer will decide either to give priority to station 1 or station 2. So these are the services offered by the data link layer to the network layer. So this is about design issues of data link layer. Thank you very much.